So here's the planes of reference in 3D, and here's the equilateral triangle that we so often see on our drawing sheet. This is a portion of the surface that the object is drawn onto. Okay, so I have a further size of the surface that the object is drawn onto. The triangle is where this portion of the axonometric plane pierces the vertical plane, horizontal plane, and then vertical plane, produces the triangle. Then I'll show you the solid, or the object. So there we have the object of it. It can pierce through this surface. That's not a problem that it pierces through it. There's nothing wrong there. All the drawing will be drawn on this surface here. Everything will be drawn on that surface there. Okay, so we've the setup of the views in their required position, the elevation and plan in their required positions. Then we put the views into their required positions, okay, in those semicircles, and that'll make sure that you'll get a foreshortened view. We're going to project from points from elevation and plan, and where they intersect, we get our isometric projection of the object. So I'll turn these lines off now. So there we go. And what I love about the model, the SolidWorks model, is that it shows you, even though this line is meant to be, is according to the question, 125, I think. So it's meant to be 125, or sorry, 130. What am I about? 130, right? If I check the size of this line, I just do dimension this one as it's on here. That's 130, all right. Whereas in the axonometric view, if I dimension this here, okay, this, all right, on the drawn will be shorter, all right. On the drawn it'll be much shorter. So well, because that's how isometric projection works. It draws a foreshortened view of the object. Then to do the curve, okay, we divide the curve and elevation up into points. We find these points in plan. The distance they remain from the end vertical plane in both views remains the same. So we find those points in plan by just transferring the distances with our compass down here. So that's the points in plan, those two grey ones. And then we project the lines up from plan, okay, and elevation until they intersect to get us points on the curves. And then to do the curve at the back, okay, we can just simply project these points backwards. So we can just basically find the thickness of that and step the thickness on the lines there. So welcome to the 2011 Section B Question P3 in Junior Cert TG. So we have the trolley. We have to draw it in isometric using the axonometric axes. Okay, so part I, draw the axonometric axes, Y, X and Z. Draw the plan orientated at 45 degrees. Part 3, draw the elevation orientated at 45 degrees. And part 4, draw the completed axonometric projection of the trolley bag. So I'm going to start by drawing my axes. So both axes are at 30 degrees. Okay, and then to set up the views at the required angles, I'm going to use a equilateral triangle. Okay, so the size of the triangle is irrelevant. Just has to be equilateral. To drop the corners down here of the triangle, they can go on any depth you want. So I'll go down 80 just for suggestion of size. Then we're going to draw in a semicircle here. Once we have the semicircle drawn in, we can use our 45 degree set square to draw in the orientation of the plan. Okay, so I'm going to draw in two 45 degree lines passing through the intersection between the y-axis and the semicircle, and then the two endpoints of the diameter. A lot of students try to do the triangles first. You should do the semicircle first. It won't cause a problem in plan, but it will cause a problem in elevation. If you do the triangle first, it won't work. Now we'll set up the elevation in the required position. Okay, the construction first. So from the corners of the rectangle, I'm going to draw out at 30 degrees, so I'll move the visualizer now. So you can go at any distance you want, but I'm going to recommend possibly 130. Okay, no, I won't recommend 130 as I wouldn't have enough room then otherwise to finish it, because the height of the elevation would be 160. So I'm going to go back 100. Okay, 60 degree line, so it's parallel to the edge of the equilateral triangle. Extend on your axis there for your center point, and then we're going to draw in the semicircle. So where what you call it, the semicircle pierces the axis, we're going to draw through a line through it, and then likewise here we're going to draw a line through there. And that's the orientation for the elevation. All right, now I'm going to go back and draw the plan view in. So I'm going to draw the plan view in its required position. Okay, the length here in plan is not given, it's found in elevation. It's 100 long. Use the 3D diagram for help. It's your best source of information. So it's 100 long. The front pouch is 80 long, all right, because it's represented here. The handle, the length of the handle is given in elevation. That's 40. Okay, the distance between the two hidden detail lines is 30. So the hidden detail lines are in 5 from the heavy lines of the handle. The widths are 40, 50 and 30. So the handle is 10 thick. The body of the big pouch is 40. The total width of the trolley is 50. And everything is stepped either off a center line. So the pouch, okay, or the side of the object starts on the end vertical plane. I'll just pause so I can get up the model. So it starts on the end vertical plane, so the object, it touches this end vertical plane. All right, I got to change those labels there. So that's where it is in plan. So 100 center line, step 40 left and right of the center line, so 40 left and right of the center line, then 20 left and right of the center line, and 15 left and right of the center line. This will be the center line here. So I'll just do in the center line lightly here. Okay, and then the total width of it is 50. Okay, and distance from the end is 40, and the handle is 10 thick. So 50. So that's the plan view done, and I'll get ready to set up the elevation. So I've marked the relevant distances I need down along the base here and up along this line here, the 75-degree line. The heights here are given in elevation. So 80 and 50 is 130 and 30 for the handle. The total is 160. The distance from here to there is 80. Distance from there to there is 50, as already described. The distance from here to the underside of the handle is 25. Okay, and the length is there at the bottom is 180 and 80 either side of the center line. So I can start drawing lines from these points parallel to the base, and from these points up parallel to this edge here, or that line, the edge U of the end vertical plane. The center points for the arcs, so they're in 25 and down 25 from their relative corners. Okay, so I can start heaving in lines now. So I'm going to make this 3D by into the axonometric projection by beginning to do this face here. So the key ideas will be that these two lines, okay, that I've just highlighted in orange, will appear as points in plan. Okay, they'll appear as this point and this point. Okay, and that this line here will appear as a point in elevation, and these 2 points here will appear coincident in elevation there. Right, so I'll start at this. Right, I'm going to label the points. I'm going to bring them up from plan and down from elevation. Down from elevation is 30 degrees and up from plan vertically. It's point A, it's point B, point 1, point 2. So I'm going to heavy them together. Now, I'm going to do this line next, and then that face there, but just not the curve. I won't do the curve, just outline of the face. Get points E and F here. To find them in plan, they're 20 either side of the center line, so they're going to be 20 either side of the center line here. So the key is these questions, you really got to use the 3D diagram they give you in the question, because it's your best bet of visualizing this object. So I'm trying to get this 30 horizontal line in real life there. Okay, it's the best bet to understand the question using the diagram given in 3D. Now, truth be told, you don't have to bring down every point at 30 degrees. Like, if you have a good understanding of this, okay, not every point has to be brought down at 30 degrees. So I want to get points E and F here. All right, so they're 15 from the center line elevation, so they're 15 from the center line here in plan. The best bet to understand these questions is to use the 3D diagram in the question given, as they're your best source of solving these. That's the line we're looking for. Now, you don't always have to bring every point up. Look, line E to F has to be at 30 degrees, all right? So it does. So I can just draw this in at 30 degrees. So there's E and F. They automatically find each other. So they do. So we're ready to do the curves, right? Now the key thing is we have to divide the curve up, okay, in elevation to establish points on it. To find them in plan, we have to transfer the distances from elevation to plan and bring the points up and the points down from here. So I'm going to divide into 60 and 30. A good technique when the elevation is inclined is to set your compass to the radius of the arc and swing from this vertex and this vertex here. Okay, that's a good technique for dividing it into 60 and 30. Now we need to get those points then in plan, so we transfer the widths of it with our compass. So I take my compass, put it on A, bring the nib to the first point here on the centre line, bring it down here to plan. It has to be on the 40mm line, so in there, not there, there. So we're going to bring these down then from elevation at 30 degrees. And then we're going to bring them up from plan until they intersect. Now be careful not to get mixed up on these points. That's commonly where students are going to go wrong. So that you could line your set square up with the point and follow down with your finger until they intersect for help. And then we freehand sketch these points in. Okay, now to get the curve at the back here, you could find, if I just get the distance of this with my compass, they're a uniform thickness, and I plot back from M with my compass. So look, I set my compass to the distance between 1 and 2. I'm going to plot back from M, I'm going to plot back from N. They're the points, so I can freehand sketch them in. Okay, now then I have to do the curve here at the front, and I'll have to do that curve there in a short while. So I'm going to approach the curve here in between EC with the same idea. So I'm going to divide into 60, 30, set my compass to the radius. Now, so I set the compass to this distance here, the horizontal distance between C and O, and I bring it down to plan, and I step it here from C, okay, along the front line. Then I go back up to elevation, and I do the same here from C to P, horizontally, and step it back down here. Now I'm going to bring the points up from plan, and the points down from elevation. Okay, so I'm bringing O down and P down. So that's point O, and this is point P. I can freehand sketch them in. And then we're doing a similar concept to what I was showing you with making it this curve extruded. Take the thickness here and step it from the letters. So sorry, that point needs, oh never mind. So we can freehand sketch them in. Okay, kind of heavy here. Right, then we're going to have the points on this side. I brought up the center line, I brought 30-degree lines across here. I'm going to take the distance between O and the center line and step it this way. It's not right to say it's a mirror, it's a translation really as such. So I brought up the center line. So sorry, I took the wrong distance there the first time. Here's the center line. Okay, so O to the center line, step it from here, and then P to the center line, and step it from there. And then I can freehand sketch those points in a minute. I'll do it neatly in a moment there. That's just a reference there to show you where it's going to be. And then for this one up here, so to find the set, I'm going to find the center line by bringing it up from plan. So that's it there. So I'm going to take the distance of n to the center, step it here, m to the center, step it here. Now I'm going to pause and freehand sketch them curves in. So I have those points marked in, and then the idea to make the back here of a 3D is the same, right, as what was over there. Here we go. I'll have it in now.